Why the frown, Ted? You got a tough one?
Nah, I was going to bounce this job to check the front shock absorbers, but there's no place to stand on the bumper.
Well, bouncing a car can give you some idea of shock absorber action if they're badly worn or leaking. But on a car like this, you'll need a road test to make a complete shock absorber check.
Well, I thought all you had to do was bounce the car to check shock absorbers.
Hiya, Tech. You're just in time to help us bring Ted up to date on shock absorber testing.
Jim's right, Ted. Bouncing a car in the shop can't give the abrupt movement you need for a complete test. You see, shock absorbers are designed to give variable resistance to suspension movement as needed. They do this so the ride has firm control on rough, bumpy surfaces, but is not stiff or harsh on smooth pavement. Now, if you try to test a car in the shop, the relatively slow bouncing movement you can apply checks the shock absorbers only where they normally give the least amount of control. Besides, bouncing may not help much to tell you which side is acting up.
Why worry about sides? Aren't you supposed to replace shock absorbers in pairs?
Only where high mileage or bad leaks make their general condition doubtful. On fairly new cars, there's no need to put on a pair if only one shock absorber goes sour.
Okay, I'm sold on the need for road testing, but how can you tell what's good or bad?
Well, first of all, you should pick out a regular test route which includes both smooth and rough pavement, and, if possible, a fairly rough railroad crossing. When you have a run lined up, take a car which you know has good ride characteristics and drive it over your test route several times at different speeds. This will give you a standard for comparison for checking the suspension ride control of other cars of the same model. Be sure to note the effects of specific rough spots along the route. If good shock absorber action handles them okay at certain speeds, your test car should do as well if its suspension and shock absorbers are up to standard.
Why bother with a train crossing if there's a rough section of pavement handy?
Because crossings with abrupt level changes between the rails call for maximum shock absorber control. This is a good test for suspension strike-through, especially at the front end. In addition, a straight rail crossing checks the shock absorber action on both sides at the same time, as first the front and then the rear wheels pass over the tracks.
If the tracks cross your drive path at an angle so the car wheels do not hit the same rail in pairs, the test will help you pick out any difference in shock absorber action as each wheel reacts separately to the rails.
As you drive over several sets of tracks, generally poor shock absorber control can allow violent pitching motion. Even at low speeds, this movement can cause repeated suspension strike-through, both front and rear. Besides this, where a front shock absorber on one side does not control properly, it'll allow a body rolling movement as the car crosses the tracks. We'll talk about other chassis conditions which can cause this rolling motion farther on.
If the body roll is caused by a weak shock absorber, how do you tell which one it is?
You'll notice that the side with the poor shock absorber has a greater tendency to bounce. However, if there's any doubt, raise the front end of the car to let the suspension hang free so you could disconnect the suspected shock absorber at the bottom. Then extend and compress the shock absorber by hand so you can check its action. As you probably know, extending a shock absorber normally provides resistance to movement. This resistance controls the upward movement of the car body or rebound of the suspension after it reacts to a bump. In the opposite direction, the shock absorber also resists movement as it is compressed. This allows the shock absorber to control upward movement of the suspension as the wheels hit bumps or other high spots in the drive path. When you make the test, resistance to movement in either direction should be smooth and consistent. If there's little overall resistance or you notice soft spots in the movement, a new shock absorber should be installed.
Well, how about leakage? I've heard that a wet area on the shock absorber body means it's losing fluid.
It could be, if the wetness is actually shock absorber fluid and not something else. Disconnect and check the shock absorber if there's any doubt. Incidentally, before you put on a new shock absorber, be sure to purge the operating cylinder of any air which may have entered from the reservoir chamber during storage or handling. Here's what you do. hold the shock absorber right side up and extend it all the way. Then turn the unit upside down and compress it. Repeat both steps several times, but do not extend the unit when it's inverted or horizontal. And when you install a new shock absorber, be sure to center the rubber mounting bushings and use the correct tightening torque. You see, bushing life can be shortened quite a bit if they're not centered or are over-tightened.
Well, I understand correct tightening, but what's this bushing centering business?
Well, the rubber bushing used in a shock absorber ring mount should be able to twist equally in either operating direction as the suspension moves. However, if you tighten the mounting nut with the car raised off its wheels, the bushing winds up when the wheels and suspension parts return to normal load position. This wind-up puts a constant one-way strain on the bushing. In fact, when you install rubber bushed parts or separate bushings anywhere in the car suspension, be sure to center the bushings with the suspension in normal load position before they're tightened. Care to add anything else, Tech?
Yep. Don't use lubricant of any kind on these rubber bushings before or after they're installed. Lubricant can allow the bushing to slip and wear out instead of flexing normally. Now back to the ride test, Jim.
You may find it easier to check a wheel at a time action when you drive on rough pavement. Here you'll have to pick out specific bumps and holes so you can compare shock absorber action on repeat runs.
Well, how about the smooth pavement part of the test run?
Compared to your standard car, you shouldn't notice excessive stiffness or harshness on a test ride. Ride control should also compare well when you drive over any thank you ma'ams on your run.
Hold it, Jim. What's a thank you, ma'am?
Well, it's a sort of smooth rolling bump which you may find at some street crossings, culverts, or short bridges. When you drive over one at low speed, this bump can cause a repeated, level bouncing motion of the car body, especially if the shock absorbers and suspension are not up to standard. At higher speeds, the car can go into a pitching bounce with repeated strike-through front and rear as the suspension bottoms. In fact, the pitching movement may try to lift you off the seat.
And you'll be glad you remembered to fasten the seat belt. Now, before Ted asks, you'd better tell us about other chassis conditions which should be checked before making a test ride.
First of all, the tires must be inflated properly. And don't forget that worn tires do not ride the same as new ones. When you check tire pressures, inspect the treads for flat spots or irregular wear, which can be caused by improper inflation, incorrect wheel alignment, or wheel unbalance. Just remember that the ride will be affected both by uneven tread wear and by the condition which caused it. In addition to tires, be sure to check the front suspension height, especially where the customer mentions that the suspension bottoms. Adjust the suspension height if needed so you can get an accurate shock absorber test.
If you forget to check out a car which has uneven front suspension height, you'll probably get a body rolling effect when crossing railroad tracks, even with good shock absorbers. And while we're on the subject of rolling, you may get a car which checks out okay in the shock absorber department, but has a one-sided rolling tendency, even on fairly smooth pavement. Where this happens, be sure to check the torsion bar on the side that tends to drop. You see, our torsion bars are specially treated and pre-stressed for use on specific sides of the car. The last 3 digits of the bar part number are stamped on the anchor end. If the numbers end with an odd digit, the bar's for the left side. An even end digit is for the right side. If 2 right or 2 left torsion bars were installed on a car, you'll find that the body tends to sag on the side with the wrong bar. This is a condition which adjustments or new shock absorbers cannot cure.
Good points, Tech. The reason for pre-stressing torsion bars is simple. All new car torsion springs tend to settle a bit at the beginning. To compensate for this, our torsion bars are twist-stressed slightly in the opposite direction. When you install a new torsion bar, be sure to inspect the new bar carefully all over for score marks or nicks. All scratches and nicks must be dressed down to get rid of sharp edges so torsion will not set up stresses at these points.
Hold her right there, Jim. We've dressed down this side of the record, so if someone will turn it over, we'll go on with the story.
It's important to inspect torsion bars because sharp-edged nicks, scratches, or score marks in the outside surface of a torsion bar are the same as open cuts. When surface tension is set up by twisting, nicks can open up and cause a fracture or break. If you dress down any spots on a torsion bar, don't forget to paint the bare metal to protect it against rusting. Like nicks and scratches, rust or pitting can also weaken a torsion bar. Now, a few final reminders on torsion bar installation. Clean out the rear anchor and lube both ends of the bar to make installation easier. Before installing the bar seal, pack the annular opening in the rear anchor completely full of multi-mileage lubricant to guard against rust.
One more thing on torsion bar replacement or adjustment. Don't forget that raising the suspension height changes headlight aiming and can also affect wheel alignment. It's good practice to check both the aiming and alignment after adjusting suspension height. While you're talking about the front end, Jim, why don't you tell Ted about checking ball joints?
Well, there's some confusion about the normal amount of play you'll find in the lower ball joints. You see, except for the Imperials, the lower ball joints on all Chrysler Corporation cars are not internally spring-loaded. This is done primarily to reduce steering effort and wear. But with no spring loading, the ball joint housing is free to move up and down a bit when there's no load on the joint. This movement is normal if it's within specification limits. However, some technicians don't know that some play should be expected at this point. When they detect this movement at a lower ball joint, they assume it's badly worn and recommend replacement. In actual operation, the play in the lower ball joints disappears because car weight normally keeps the ball joint parts seated. In fact, with torsion bar suspension design, the full front-end weight load is carried by the lower ball joints.
If the parts of a lower ball joint can move up and down, what keeps it from pulling apart when the going's really rough?
For one thing, the parts are held in by a retainer which prevents pull-out. Besides that, as the wheel and suspension assembly starts to drop downward in the rebound direction, the torsion bar reacts more quickly than the suspension, so the ball joint remains properly seated.
Good points, Jim. If you were paid for every good lower ball joint that's been junked, you'd be rich. Now, how about a quickie on checking ball joint play?
Just roll a jack under the lower control arm near its outer end and raise the wheel off the floor. Then, lift the wheel upward so you can check the movement of the lower ball joint housing. There should not be more than 70 thousandths of an inch of housing movement, or the ball joint should be replaced. There should not be any play in lower ball joints on Imperials beginning with the 67 models.
That 70 thousandth spec is brand new and applies to the 68 models. On earlier model cars, the old 50 thousandths of an inch limit still applies.
Thank you, Tech. Now, on your inspection, be sure you check lower ball joint play at the joint housing. If you take a gamble based on wheel movement alone, you could be misled by loose wheel bearings.
What's the story on the upper ball joints?
The upper ball joints of all our cars are spring-loaded to eliminate the kind of play that's normal in the lower joints. To check these joints for wear, you can use the same setup as for checking the lower ball joints. Here, you move the wheel in and out at the top while you check the joint. If there's any movement at all, replace the joint. But don't be fooled by lower ball joint movement or a loose wheel bearing.
What happens if you don't use the multi-mileage lubricant specified in the service manual for chassis parts?
If you use a lubricant which doesn't meet the same standards, it may not lubricate as well or last as long, so parts' life can be shortened. When you do a lube job, do not over-pressurize the seals at ball joints, steering arm, idler arm, and tie rod ends. If these seals are ruptured, they'll have to be replaced so the parts will be protected against premature wear. Now, here's a quick one on linkage adjustment. You normally adjust both tie rods to shift the steering gear arm to correct the steering wheel position if the wheel spokes do not center in the straight-ahead position. However, If you install a new steering gear arm and then run out of tie rod adjustment before the steering wheel spokes are centered, you'd better make sure the steering arm's the right one for that car. You see, some steering arms differ only in the drop angle of the arm, so mix-ups are possible. Where steering arm and idler arm angles are not the same, the center link will be low at one end, and this limits the amount of tie rod centering adjustment. In addition, if the center link is tipped from its normal horizontal position, front wheel toe-in can vary quite a bit from the basic setting as the suspension moves up and down. This variation reduces directional stability and can cause steering wander. Where you suspect the wrong steering arms installed on a car, set the wheels straight ahead and check the space between the torsion bar and the center link at each end of the link. If the spacing is uneven by more than 1/4 of an inch, the arm may be incorrect for that car. But if the steering arm's okay, the uneven center link alignment can be caused by an incorrect steering gear mounting position. You can reposition the steering gear and its arm by shimming the gear mounting. However, where you shim the gear, don't forget to realign the steering column.
Since you've mentioned wheel toe, this might be a good place to review a few points on wheel alignment and tire wear.
Right, Tech. Of course, all front wheel alignment adjustments must be correct for good steering and handling, but toe-in and camber are the most important where tire wear is concerned. Incorrect toe-in causes a wiping or scrubbing kind of wear at the edges of the tire shoulders and tread ribs. This wearing action leaves thin feather edges on the inner sides when toe-in is excessive, or on outer sides when there's toe-out. Compared to this, too much camber causes rapid wear at the tire shoulders. Excessive positive camber mostly affects the outside shoulder, while negative camber works heavily on the inside shoulder. Of course, there are other tire wear causes such as under or overinflation, delayed tire rotation, soft shock absorber action, unbalanced wheels, high road speeds, jackrabbit starts, and excessive cornering. However, these factors depend mostly on the customer.
All right, Jim, but why are toe-in and camber needed at all?
Reduced to the simplest terms, you could say they're both a kind of preload. It's a bit like the reason I mentioned earlier for pre-stressing torsion bars. Here's what happens. Ideally, all four wheels should be vertical and run in straight lines to get the best tire mileage. However, front tire rolling resistance tries to make the wheels toe out. And when the car is loaded, movement of the suspension tilts the wheels inward at the top. To compensate for these variations, we preset the front wheels to give them toe-in when the car is standing still. When rolling forces act on the tires, the wheels move from toe-in to a straight-ahead position. In like manner, the front wheels are also set with positive camber, which tilts them out at the top when the car is not loaded. This allows the suspension to move the wheels inward toward the desired vertical position when the car is loaded normally.
Well, you said all four wheels should run straight under load. What about the rear wheels?
The same kind of load compensation is built into the rear axle housing for proper running alignment. But here, because traction power is applied to the tires, the wheels tend to toe in instead of toeing out. In fact, if you check rear wheel alignment for any reason, don't be surprised if a slight amount of positive camber and toe out shows up on your machine. Here again, when loads are applied, normal deflection of the parts moves toward the desired alignment. Incidentally, I've heard of some technicians who have blamed heavy tire shoulder wear on the normal camber and toe out that's built into the rear axle. They incorrectly assume that anything other than 0-0 alignment means a bent axle. Actually, heavy shoulder wear that's equal on both sides of a rear tire is usually caused by underinflation and delayed tire rotation. If this shoulder wear is unequal, it could mean that the rear axle is not tracking properly. And another thing, before you blame poor rear wheel tracking on a bent rear axle, make sure both springs are equal in length and that the axle has not shifted on the springs. If the axle housing is bent, it should be replaced. And that concludes my lecture for today.
Jim and Ted have taken us from front to rear with highlights on car suspension servicing. Some of the points in this roundup are new, others aren't. But it never hurts to double-check your know-how. Car suspension and wheel alignment are big subjects, so you'll have to add your service manual instructions to the spotlight treatment given here. Extra information is also included in your reference books for this session, so don't forget to read them through. See you at the next meeting.